Hello, everyone. Thank you so much for joining us today. Today's speaker series is a part of our community partnership speaker series. We're going to hear from TN faculty member Alex Webster here at the University of New Mexico and Mori Hensley from the Santa Fe Watershed Association. Thank you so much to both of you for presenting today. We're really excited to hear about your research. And thanks for being a part of this series. I'll go ahead and hand it over to the two of you to introduce yourselves more formally and go ahead and get started.
Thanks, Bax, and thanks so much for everyone for being here. It looks like we have people from a variety of places in the audience, so I'm excited to see some folks from outside the TN as well as in the TN. So thanks all for being here. I'll let Mori introduce herself more in just a minute. I just wanted to start by introducing myself. And before I hand it over to Mori for the first half of the presentation, I'm a assistant professor at the University of New Mexico. I've been working up in the Santa Fe Watershed since 2023 with the support of the Transformation Network and other funding that I'll mention. And I've really loved working there and working with Mori and our other key partners, including members of the City of Santa Fe Water Division up there. So I did want to note by just, let's see if I can move to the next slide. No? Yeah. Yeah, so this whole series is about community partnerships. And I did want to note before we dove in that I don't see either Maury or I as purely inside or outside of the academy, meaning like academic research land. We just have discussed in the Transformation Network that this binary is problematic because it kind of suggests that there's some different level of expertise on the two sides of it in our exploration of convergence research in the TN. And so I wanted to note that I see both Maury and I as spanning those boundaries, and we both have expertise on the issues and the important things in this watershed. And so I wanted to note that, and I think you'll see when Maury presents how knowledgeable she is as well. And it's really through the combination of our perspectives that I feel like we're able to move important work forward on this concept of headwater dependent communities and climate resiliency and things like that. So with that, I want to hand it over to Maury to tell us a bit about her organization and her partnerships with academics, including in the past as well as me. So take it away, Maury.
Thanks so much, Alex, and thank you all for being here. Great to see some familiar names. Um, I'll speak a little bit more about the Santa Fe Watershed Association as we continue, but yeah, thrilled to talk about resilience, one of my favorite things and obviously a buzzword. So yeah, let's go to the next slide. I will just give a brief overview of what the watershed itself is, what our organization is, and like Alex mentioned, some of the past and ongoing projects that we're kind of partnering with academic researchers on. Next slide. So I just wanted to preface by saying that when I think about resilience, I definitely think about this model from Gunderson and Holling. There we go. It seems like someone might not be muted. Okay, now we're good. I was lucky to study with Lance at Emory, and so this kind of model is baked in my brain. And so just as I'm thinking about and speaking about resilience, know that I kind of have this framework in mind. Next slide. Now moving on to the watershed itself, of course, just to orient us all, especially for those who may not be in New Mexico, we are nested within the Rio Grande watershed, which you can see on your left, the Huck unit, and then finally the Santa Fe River watershed itself. The river is about 40 to 45 miles long. And for such a small river and watershed, it's incredibly diverse and incredibly complex. And the green area within that red outline that you see to the east side of the map, the right side of the map, is the area that we'll be focused on today, which we commonly refer to as the upper watershed, which is mostly overlapped with the Santa Fe municipal watershed, although some of you are familiar with some of our kind of painful discussions about how to distinguish those two words. But even that area is quite complex. And so I'm thrilled to partner with Alex and a lot of other folks looking to steward that landscape. Next slide. So to give you an idea of kind of the main breakdown that folks in this area use when describing the Santa Fe River watershed, we describe the upper watershed as related to the sort of alpine forested headwaters of the Santa Fe River. So the uppermost photo is Santa Fe Lake, which although Alex corrected me, most people think of it as the headwaters of the Santa Fe River. And Alex also shared recently that it's the southernmost alpine lake of the Rocky Mountains. So very, very cool. Fun fact, in the upper watershed, there are also two reservoirs that are managed by the city of Santa Fe, and they provide for 30 to 50% of the drinking water for the city of Santa Fe, in addition to San Juan Chama water and groundwater. So an incredibly important landscape. It's been closed to the public since 1932 by an act of Congress and is co-managed by the U.S. Forest Service and the city of Santa Fe, as well as other partners, including the Santa Fe Watershed Association, the Nature Conservancy, and Audubon Southwest. And then we meet with other partners as well. And I can go on, but let's move on to the middle watershed. The middle watershed we typically refer to as kind of the urban watershed. This black outline is approximately the city of Santa Fe municipal boundaries, but as you can kind of see from the map underneath, the urban areas that incorporates parts of the county as well. So you can see that this area of the watershed, the river is often dry. There's a lot of trash. There's a lot of more urban hydrology issues, stormwater, flash flooding, things like that. Next slide. And then we have the lower watershed, which we often refer to as kind of the downstream western part of the watershed, west of the city municipal or kind of greater Santa Fe area. This is an incredibly unique ecosystem and, a lot going on down here that a lot of people kind of forget about. But there are several very significant traditional communities. The Pueblo of Cochiti is where the Santa Fe River meets the Rio Grande, just downstream of Cochiti Dam. I've heard some people say that the springs in the lower watershed form the largest Cienega wetland complex in the state of New Mexico. So even though we're focusing on the upper watershed, the intrigue and the diversity and the significance do not end there. It's all connected, and that's then a tie-in to kind of what the history of this land is and what the Watershed Association does. So next slide. These are just some pictures of examples of some of the legacies that we're dealing with in the watershed and of course in New Mexico and the continent more broadly, but damming, logging, overgrazing, hunting predators to extinction, extirpating beavers, mining, you name it. All of these impacts and more have had profound, we're continuing to deal with the fallout of these histories on the landscape. Next slide. And so there are a few of these ongoing issues I've listed here. And of course, this graph that most folks on the Zoom are probably familiar with, the trends that we're seeing due to climate change of temperature and precipitation, which I think in one way or another all relate to all of these other issues that we're facing. So The takeaway, of course, as all of you know, is that we're in a crisis on many fronts, and it's really important that we work together and figure out how to be most efficient and effective in stewarding our land together moving forward. Next slide. And that's where the Santa Fe Watershed Association comes in. We are a small nonprofit, community-based organization based in Santa Fe, and we focus specifically on that map, the Santa Fe River watershed. And I think that we're the only entity that focuses on this area in its entirety, but specificity, I guess. So our mission is to build a thriving and resilient watershed through collaboration, stewardship, and education that inspires us all to care for the land, water, and each other. We were founded by hydrologist Paige Grant in 1997. So we're coming up on our 30th anniversary. And since the beginning, we have really emphasized the need for collaboration across agencies and interest groups to have a more holistic approach to managing our watershed and recognizing the interconnections between those different geographies and sectors. Next slide. I won't read our values out, but just to emphasize again, we are a small community-based organization. We're actually the biggest we've ever been. We currently have 9 staff of working various hours per week, but everything we do focuses on centering the Santa Fe River and our connection to it, and really recognizing the watershed as our physical common ground and the thing that we don't have a choice but to figure out how to steward together. And so I feel very proud of that legacy and the things we've been able to accomplish as a small team, and really looking forward and feeling very motivated for the work we have ahead of us. Next slide. I was really lucky to work on this project with Dr. Courtney Flint and Leonard Henderson and Todd Kaplan early on in my time with the Watershed Association. And this was my first connection with the Transformation Network, and my first connection with working through a nonprofit in partnership with academia. And this project really was formative for me in the way that I understand our watershed, understand the roles that the Santa Fe Watershed Association plays in this very diverse and complex landscape of partners and stakeholders. And so I wanted to touch on it briefly. It's on our website, so you can check it out, and Alex will talk a little bit about it as well. But the finding of this study was basically three key takeaways were that sometimes unexpected common ground exists between diverse stakeholders, that there are process-based opportunities for us to work together and make tangible impact and build resilience together. And I think the most significant takeaway for me, I ended up becoming executive director of the Watershed Association, and this concept of interactional capacity and the finding that our watershed has low interactional capacity really stuck with me, and I think it has shaped the way that I have kind of led the Watershed Association and built on its legacy that, even if we weren't already using these words, I think they really speak to the work that we have always done and continue to sort of focus our work moving forward. Next slide. Dr. Flint defines interactional capacity as the ability of a local community to work together and mobilize resources around shared interests in times of need. And even for such a small area, our watershed is incredibly disconnected for a variety of reasons. So we're all in our silos, we all have our separate interests, and we're not talking to each other. And oftentimes we may not even know that other stakeholders exist, or that projects are happening, that research is happening. And this leads to a lot of redundancy, a lot of waste, but also just a lot of unnecessary conflict and competition. So the goal is really to bring these different interests together through sort of that shared common ground. And that's something that we at the Watershed Association really strive for. We kind of see ourselves as the weavers in this community, and we see that as the way that we participate in change making is bringing people together and understanding what's going on in these different sectors and figuring out how to connect us. Next slide. So just to dive into interactional capacity a little bit more, this is a reproduction of a graphic that was in the report. But as we all know, we're often on grant deadlines, project deadlines, and a lot of this kind of background work gets relegated to the sidelines, and we don't end up prioritizing this, whatever sector we're in. Often time is very, very scarce, but also we may not have the tools to understand even how to build trust, to establish shared goals, to respect, as Alex was saying at the beginning, to create a framework of integrating different ways of knowing, that we sort of have these ranked ways of respecting knowledge and expertise, and that can really be detrimental down the line. And so how can we start to invest in sort of building this network even before a tangible outcome through a grant deliverable or something like that is forming? But how can we, I was in a conversation yesterday with a partner saying, how can we actually if we're baking a cake, how can we shop for the ingredients together and talk about the recipe and bring all of our materials and work on whose oven is going into before, and instead of just one person bakes the cake and then passes it around and everybody just puts a little bit of frosting on it at the end. That's not interactional capacity. That interactional capacity, that true collaboration is co-creating things throughout the entire process and having a network kind of ready to go. And that is really important for resilience, because of course, resilience is a system's ability to respond to change and disturbance. And so if we already have those relationships in place, we can respond much more proactively and effectively than if we're in a crisis and suddenly having to build relationships or reinvent the wheel immediately. So I think this is really a framework that guides a lot of my work. And if you go to the next slide, and I think it relates to the partnership that we have with many entities, but for this talk, I wanted to focus on academic researchers, government agencies, and community groups, because building relationships is one thing, but then maintaining those relationships and actually getting work done together is the next step of that, which we'll come back to. But I think that, thinking about the tangible work we're doing and the roles that these different pieces of the puzzle play is essential, that we're all bringing our expertise and our resources to situations. We'll be talking about management of the upper watershed. We're all of our perspectives are really necessary to most effectively manage this incredibly important resource. Next slide. This might be, so that kind of brings us back into the real world, using this framework of interactional capacity. Way back in the late 90s and early 2000s, our founder Paige Grant wrote this Santa Fe River Watershed Restoration Action Strategy, which Alex, correct me if I'm wrong, but I think was one of the first documents that kind of catalyzed the co-management of this landscape. With fire suppression and the closure of the watershed, not much had been done other than managing the water supply. So this document was really foundational for setting up this collaborative co-management, starting to actively manage our forests, trying to reintroduce fire to the landscape, these very important themes that continue to this day. In 2009, the partners that I listed earlier co-wrote the current management plan. It was updated in 2013. It's a 20-year plan that outlined the ways that especially the city of Santa Fe Water Division and the U.S. Forest Service would work together with the other community partners. And one of the most significant things to come out of this plan was a payment for ecosystem services scheme where city water customers contribute financially part of their utility bill to do forest management in the watershed. And so at the time, that was a pretty visionary concept. And that is still something that we as partners are very proud of. It's now 2026. Some parts of this plan have been very successfully implemented. Other parts have hardly been implemented at all. So our kind of management group has started brainstorming about how we can update this plan, how we can, and we've brought in more partners like Alex at UNM, the Pueblo of Tesuque, Forest Stewards Guild, Trees, Water, and People, to really bolster the conversation and make sure that, yeah, as we work on updating this plan, we learn the lessons of where the successes happened and where the improvements still need to be made. So I think that's it. Next slide. Great.
Thanks, Maury. And Maury will come back at the very end to wrap us up, but I'll talk a little bit about my group's research here that I like to think of as use-inspired convergence research, which might be a bit repetitive, but have slightly different meanings. So I wanted to start by defining use-inspired research. This is an approach that kind of tries to bridge basic and applied research by aiming to generate fundamental knowledge while also addressing specific societal problems. And people often use this chart you see on the left here that shows the overlap between considerations of use and questions for fundamental understanding. And as you can see, the overlap is that use-inspired research. And it's been my aim for a long time to hit those and really emphasize those overlapping points while also doing fundamental research in my research program. And this has been a great place to do that. The Transformation Network has explicitly defined our research network's approach to convergence research. This is a newer term that originated by the National Science Foundation and was built upon the foundations of various perspectives on transdisciplinary research. And it was still when we started our research network under the umbrella of convergence research that it was funded under, we still felt like that was not a very well articulated or complete definition. And we also wanted to define what tools are useful for approaching this type of work. So me and a bunch of others in the research network worked on this and came to define it as research that emphasizes response to societal problems and novelty and innovation through both the deep integration across our traditional academic disciplines and also partnerships with people outside the academy. And we in this diagram we have on the left, which Mindy affectionately calls the TN octopus. We have in the middle the tools that the network uses to navigate how to approach this. And the two that I'm going to emphasize today are systems thinking and in community engagement. And Maury already discussed Courtney Flint and Leonard's and others, as well as she is also an author on this report on investigating stakeholder priorities. This work happened just as the Transformation Network. It started before we were funded, and then it was completed during the starting up of the Transformation Network. And so it was there at a really critical time where it was able to help us kind of do some of that community engagement of asking a diverse set of stakeholders what the priorities are without the challenge of the time that it takes to do that if you're starting from scratch, which is always a problem with doing grant-funded academic research that happens on 3 and 5 year timelines with community engagement. The timeline is one of the biggest barriers to doing that effectively. So we were really lucky to have some of this groundwork done by Mori and Courtney and others. And one of the things that, one of the big take homes that Mori already showed was that it identified a set share of priorities that really we wanted to focus on in the transformation network as a point of as that center of that diagram that Maury showed that can help foster interactional capacity. And those common priorities were about water flow, wildfire threats, water quality, ecosystem health, and water conservation. And a lot of those issues are not entirely, but are largely focused on the upper watershed. And so we've centered a lot of our research there, although we do have an eye to things that are going on in the lower areas as well that I would love to work on as my research program continues. And so I am not going to be able to do an exhaustive overview of all of the great work that people as part of the TN have done, though I'm just going to give you a very brief look at 2 example projects, both of which are still in progress. So I want to emphasize that these are preliminary results. But the first one is this. I coined my PhD student Will coined this term freshwater influencers, which I think is a really apt description because this work is identifying priority subbasins for watershed management using hydrobiogeochemical indicators. And the second one is one led by TN postdoc Ray Zhang, and it is about identifying systems thinking archetypes that point to systemic challenges in watershed management. So for this first one, it's focused on the watershed above that upper McClure Reservoir that Maury talked about. So it's really focused on the upper watershed, I often call it, and all of the subbasins that are contributing to that first water reservoir. And this work has been led by TN PhD candidate William Mejia Garcia. He became a candidate yesterday, so congratulations, Will, for passing your comprehensive exam. And we started this work with Will and I did with funding from the Transformation Network, and we were able to leverage some of the early results to fund a second Department of Energy project called Quest, which is comparing the Santa Fe watershed to 4 other watersheds across the US. And that project is really getting at that fundamental research part of that use-inspired research definition that I mentioned of what can we find in common across these really different places. But the work with the Transformation Network especially is really focused on management implications, and that's what I'm going to focus on today. So our major research questions are asking, do subbasins vary in their contributions to the amount and the quality of water flowing into the reservoir system? And can we identify those subbasins and understand a bit why their contributions vary? So asking questions like, where is the most water coming from? Where is water lost? What can we learn about forest health from subbasin exports? Are there landscape control points on water quality? And does the stream network itself modify water quality? And if so, where? These are all to get at, where we might, if we have to make hard choices about where to prioritize management, where we might want to do that. And then finally, this is all towards an eye of can we improve predictions on how change in the upper watershed will impact exports into the reservoirs. And this bit of work I won't touch on today, but there's been quite a bit of process modeling work that's being done and is in progress that will take these empirical observations that I'm going to talk about today and put them into more predictive models that will help with watershed management. So the data collection is shown on the right here, and in total, by the end of this next year, we'll have 3 water years of data on this topic. The first are all these little black dots on the watershed are places where Will and his team and others, and sometimes me, go out and take water samples and also take for chemistry and for stream flow to get at how all these different subbasins contribute to what ends up downstream in the reservoir. And Mori, actually, we were really lucky to have her come out on one of these synoptic campaigns in the upper watershed. So it was great to have her help carrying water bottles and whatnot. Was that last summer? Yeah. And we also have 13 stations where we're continuously monitoring stream flow to get at the total where the water is coming from and what places are disproportionately contributing to that. And then we also have water quality sensors in those 3 locations, the yellow, green, and purple dots you see on the map along the main stem of the river that are monitoring total loads of total suspended solids, nitrate, dissolved organic carbon, and particulate organic carbon from 3 major regions in the upper watershed. And this map shows the areas that each of those water quality sensors is capturing. And I'm going to focus today on something that Will and I have been working on, which we're calling a source area export residual analysis. So here I'm showing the volume of water or the mass of solutes on the y-axis as predicted by the subbasin area contributing to it. So like the simplest watershed theory would predict that as you have more subbasin area contributing to runoff and solute export into the stream network, you would get more water or more solutes from that location. So that's sort of our null hypothesis. And the distance of these points from that line is the residual of that relationship, meaning how much it varies from that very basic null prediction. And so we calculate those differences from the line or the residuals, and it gives us a sense of what subbasins are contributing less than expected by area alone and which are contributing more than expected by area alone. So it gives us a picture and kind of summarizes a lot of information about where there's disproportionate effects of subbasins on total exports. And here is what the results look like. So here on the left, I have the freshwater export residual. So this is the amount of water flowing out of each of the subbasins that we are sampling. So each of these dots is the outlet of a subbasin in the watershed. On the x-axis, we have mean subbasin long-term precipitation. So this is along the climate gradient of the watershed from the lower watershed that gets less precipitation to the tippy top of the watershed where we get a lot of snow and higher levels of precipitation. And you will be shocked to learn that when a subbasin gets more precipitation, either in the form of snow or rain, it produces more water. So this was expected. And so what you're seeing is that the dots above the 0 line are ones that are contributing more than you would expect from the area of the subwatershed alone. And the ones below the lines are contributing less than you would expect from area alone. So not an earth-breaking finding, but it definitely kind of confirms what we would expect. And it highlights that upper area, which are all those blue points, are really like the place where a lot of water is being transported down into the reservoirs. And this is really the area from a water quantity perspective that you would want to really preserve and understand and potentially manage for water. You can see that these middle sites, which I'm showing both on the map and on the plot in red, they kind of go down as you go down the watershed. And what we've determined from this, as well as a lot of complementary measurements, is that there's loss of stream flow in the main stem river from that upper to lower red point on the map. So this could be just a we want to investigate why this is, because it could either mean that there's some kind of geologic contrast that's causing seepage and loss of stream flow along the main stem, or it could possibly be an indicator of elevated evapotranspiration in that part of the watershed that is causing a loss of stream flow to downstream. Okay, so the other quick finding I want to highlight is about nitrate. And nitrate is a water quality concern at very high levels, but it's very low right now, at least in the Santa Fe watershed, which is great. One of the reasons why this is a really important water source for the city of Santa Fe. But it is also an ecosystem indicator of disturbance. So on the right, I'm showing a classic watershed study from New Hampshire that's showing that when you deforest a watershed, like you can see in those treatments in the picture there, you get a huge flush of nitrate out of the system sometimes, which is what the plot below is showing. And that's because nitrate is a limiting nutrient for plant growth. And so if you remove the plants or disrupt their ability to take up nitrate, you're going to have more of it transported to the stream and out of a watershed. So for this reason, we know that it's connected to the productivity and resilience of the vegetation on the landscape. And that if you see elevated nitrate, you would expect that there's some change in the nutrient uptake rates in the watershed. And this is especially true in Santa Fe because it's a very nitrogen limited system. So I want to put this same plot of the water export residuals up, and I want to highlight these two subbasins that I've highlighted in red here. And you can see that they're in the lower watershed and they export less water than you might expect from area alone. So then if we look at the same residual analysis of nitrate, we see that they've moved up way above the line now. And this is really unexpected because most of these points stay in about the same place where the amount of water they're flushing out corresponds to the amount of nitrate that they're transporting. And the fact that these two are really elevated suggests that they're exporting a lot more nitrate than you might expect. And we have this indicator not just from this analysis, but another one that's called leverage that I won't go into today. But we have it also for this additional subbasin that I'm highlighting on the right in that middle elevation of the watershed, suggesting that it's exporting kind of excess nitrate. And then finally, when we look at the storm loads from our continuous monitoring, we expect that we would see the exports going just linearly up as you go down the watershed and more contributing areas increasing. But we see that that green section there in the middle is actually elevating the nitrate loads during storms of the whole watershed. And so all of that together really suggests is a strong indicator that there's a lower amount of nutrient uptake rates happening in this part of the watershed, which could be an indicator of poor forest health and disturbance. And you can see when you hike through the watershed that that middle elevation of the watershed has experienced a lot of die-off of vegetation. It's all those gray trees in the picture there, where this is sort of the climate meeting point at the lower and upper parts of the watershed where a lot of the species there are kind of on the edge of their tolerance climatically. And also there's been a combination of drought and beetle and insect outbreaks here that has caused this die-off. So we need to verify this, but my hypothesis right now is that this die-off is contributing to those nitrate levels. And the fact that we're seeing those nitrate levels is an indicator that there's a pretty substantial fundamental change in the nutrient retention capacity of this ecosystem that could influence its ability to be productive into the future. So I want to touch on the management implications of this, which is that the upper watershed is this sort of water tower that's really balancing water quality. The middle watershed seems to have, in data I was not showing today, quite a few levers for influencing water quality and does have some indicators of poor health. And that lower watershed, our data is showing, contributes relatively little to stream flow and has very little influence on water quality. And this is important because that's the part of the watershed where most of the forest management has been focused. And it's worth considering whether that's the most important place from a water quality and water quantity perspective to center our management efforts. Okay, I'm going to briefly talk on this, touch on this other project as well. And this is work led by myself, Yolanda Lin, Ru Zhang, and Mori Hensley is also participating in this. And this is looking at using systems thinking to identify management challenges. And I want to start by talking about what is lock-in. This term is something that's part of the Transformation Network's Guided Transformation Framework, which you can read about in this paper that I have here. But basically, if you think about resilience theory, which Mori already mentioned, and you think about a cup like the one on the left being the conditions that a system is in, where the system is the little ball. And when it's in a state like this, it can move around inside this ball. And we think about resilience of a system as being a deeper cup like the one on the right, which means that the system state cannot move around as easily. It's not as, it's more resilient to perturbation because it's down in the bottom of that cup, which represents the resilience and feedbacks of that system. And the lock-in is a term from the outside of the resilience literature that gets at the idea that some forms of resilience are not helpful resilience, and that you can have a system state that you maybe don't want, that a certain set of feedbacks are entrenching and making it hard for the system to move into perhaps a more desirable state. And so it's sort of the opposite. It's like a kind of unhelpful resilience idea that challenges the ability to go in new directions in management. So our team is looking at this idea of systems thinking archetypes to get at how to identify lock-ins and what tends to hold on to them. And the one that I'm showing here is one example archetype that we're thinking about that's called in the systems thinking literature success to the successful. And it's the idea on the left that if you have two systems or two conditions that you are going to allocate resources to, we have a tendency, and systems have a tendency to want to reward the one that is going well and ignore the one that is not going well, even if they're coming from the same resource pool. And that kind of bias in our use will increase and entrench the success of in here A and kind of entrench the lack of success in condition B. I think of this sometimes as like if for all of the people who mentor students out here, you might be tempted to always give more resources to your more successful student, to the, maybe less to the detriment of another student. And that ultimately doesn't help the other student overcome the barriers that they're facing, right? So we conducted a systematic, and by we I mostly mean Ray, conducted a systematic literature review to identify lock-ins that might be influencing watershed management in Santa Fe. I won't go into this, but it will be out there. And one of the ones that we're considering, I need to step back and give you a little information about management in the watershed. So on the left is a map, again, of the Santa Fe watershed. And here in orange are the places where there's been forest thinning and pile burning to reduce the fuel loads and decrease the risk of catastrophic fire. And then you can see that middle hashed area. Actually, the whole upper area with the parallel lines through it is a wilderness area, part of the Pecos Wilderness. And the hash area is an area in the wilderness area that has been suggested for this kind of treatment, but has yet to be treated. And the elevations here, I have here the estimated fire return intervals that Ellis Margolis estimated in the watershed. And you can see that both of them should have fire return intervals of between 4 and 30 years. And these numbers aren't actually statistically different between the lower elevation ponderosa pine and the mid elevation mixed conifer. So What we're considering, and this is preliminary work on this idea, but is that the wonderful, successful amount of forest structure restoration that has occurred through these forest treatments in the lower watershed is resembles this kind of success to the successful archetype where the familiarity and ease of access in this lower area has allowed there to be a lot of treatment, which is super important. But that perhaps that has been to the detriment of resources going to that middle portion of the watershed that also needs treatment, but which is much more challenging both for funding and for risk of catastrophic fire. And this archetype suggests that, that is a reinforcing feedback loop because if we don't do treatments there, the risk remains as high there to then do treatments there. And this is something Mori and I and the city are all talking about a lot right now. So it's been really great to do this. And our empirical work really suggests that there might be really important water quality reasons for managing this part of the watershed as well. So our overall goal is what we want to do with these projects and other ones I wasn't able to highlight today is to take all this academic work and work with Mori and these other partners listed here to make sure that the update of the watershed plan that we're all working on now is informed to the best of our ability by the research that's going on in the transformation network. So that's what we have a bunch of initiatives in progress on right now, and hopefully more that we're applying for funding for in the future. So with that, I will pass it back to Maury.
Thanks so much, Alex. And you can go to the next slide. Yeah, just to wrap up again, I think the goal of this presentation and of our partnership is really to use this framework of common interests and interactional capacity and like doing this groundwork to support adaptive management that we all have very important roles to play, that we can be adaptive in our own spheres, but to be adaptive and interactional at the same time so that these planning and implementation efforts are being informed by current science that is speaking best to the current conditions on the landscape is, as I think, is the shared interest that we all have. And I'm encouraged that we all are seeing that importance more and more. And so I feel really lucky to get to be part of this bridging work between, our partners at government agencies and our partners in academia, as well as our other partners in kind of the community practice sphere. So yeah, thank you again for you can go to the next slide and we're happy to take any questions and feel free to get in touch with us. Oh, I also I forgot one thing that that I was going to say, which was that in addition to the watershed plan, you heard a little bit that Alex and I are working together in a couple of different ways. The Watershed Association is also working on a full watershed restoration plan for the entire Santa Fe River watershed. And we have a lot of questions coming up. So I think there's so much potential for future partnership between academics and community partners and government agencies and other interest groups. One question in particular that's coming up for us that this watershed plan is a great example of is what makes a successful plan. We are seeing so many examples of plans and facets of plans that have never been implemented, but the recommendations just keep getting recycled in other, in more and more plans, but the work doesn't get done. And so for folks looking for questions to study, I think this is a big one coming up for us is what kind of partnerships make successful plans moving forward and keep them alive. So yeah, wanted to insert that, but yeah, happy to take any questions.
And I'll just vouch for Maury being just such an awesome partner on this kind of work. So if you, please don't hesitate to reach out to her about this if you want to work on any of those kinds of management planning kinds of questions. I think it's a really interesting research area. Yeah, so we can take any questions.
Folks should feel free to either unmute and ask or feel free to ask in the chat too if you have questions. Thank you so much, Alex and Maury. Also, great to hear about your work.
Yeah,
Sure.
sure.
Thanks, Alex, and thanks, Maury. Um, I probably had a lot of questions in my head, but the last thing you mentioned, Maury, about what makes a successful plan, is the last one in my head. And as a planner, that certainly intrigued me, but I'm curious if your question is what makes a successful plan or what makes a successful action listed in a plan. So that might be something to think about, that it's not the plan, it's that not all of the actions in the plan are ready to move forward for any number of reasons.
Yeah, thank you for that distinction. I think we're definitely seeing both, that there are plans, like I mentioned, the Watershed Restoration Action Strategy from 2002, which is still a foundational document for a lot of the work we're doing. But there are other plans that have been done that have basically been forgotten even before they were completed. And so, yeah, I think there are a lot of challenges, and in terms of us addressing our real challenges that we have, making sure that our planning efforts are actually leading to something is definitely a goal I'm sure we all share.
Mindy.
Hey, Alex and Maury, I just want to thank you both so much for sharing your work with us. Um, and I had to jump off. I'm going to be teaching here in just a few minutes, but I just wanted to recognize that this work really represents the type of work that I think one of the messages that we have in the Transformation Network is that this work is the result of like momentum that gets built over time. And I want to acknowledge how Maury sort of mentioned the work that she did with Todd and Courtney from a Water Smart grant that she did with them. And then Yolanda is actually publishing out of work that had been done with Body Soul. And then Alex is now working with community partners that Maury has introduced that Maury introduced her to. And then now Alex and I are part of a new team called For New Mexico, and there are a bunch of those folks on this call. I want to acknowledge that they've come in to learn from the Transformation Network team that's going to be carrying work further forward in the watershed. So this is how it's built. This is how it's networked over time. It's woven in, but the real through line are people like Maury, who are committed to a place and a river. And so I just want to say before I have to go, my deep gratitude for people like you and for you specifically and the work that you do. I so appreciate it. And it takes so much in so many different ways, and it shows up in very different contexts. I have a million questions for myself. I don't get to spend enough time with you, but hopefully I will soon. So thank you in advance for all the work you're going to do, but thank you right now for all the work you've done in the past with us and with so many others. So just so appreciate you. And I just love to see the research, but I also love to see just all the different things. So really appreciate it. Thank you.
Thanks so much,
Thanks,
Mindy.
Mindy. That was a great, I was struggling with what to include in all this and what not to. So thanks for all those shout outs, and I could do more. But yeah, and definitely big kudos to Maury for
Could all always do more. But anyway, I'm going to go off and but
thanks.
nature and society now. All right. Bye.
Yeah, and I'll add, I mean, Maury's just like you mentioned this, Maury, but I think like the role you're playing as the connective tissue in the Santa Fe Watershed Association is like such a critical role that takes a rare personality to be able to do. So, thanks for filling that. This is just becoming a thanks, Maury. Are there any
I could
other
log
questions?
off, but thank you. Thanks, everybody.
He's like mortified.
Well, I can echo. I mean, I think that something that I've really learned through this process is like, we're all weaving our networks in our own ways. And so making sure that those are overlapping, like the work that Transformation Network and 4NM and Alex, you all are doing, you're understanding kind of like these larger landscapes and what is happening in the academic realm. And, our partners in government agencies are connected to all of their partners. And so I think being able to come together and have this awareness of what's going on and where the overlaps are is really exciting to be part of. So yeah, thank you.
Yeah, and the hope is, long-term research, especially in, with fluctuating funding climates is really challenging, but I think like having that commitment in our research programs to at least in parts of them to like stick with a place, and especially when it's community engaged work, to try and continue funding. And I feel really lucky that we've been able to do that through this new 4NM project that Mindy shouted out, and many of the people on the call are part of, that we're going to be able to continue that work in that way. Great. Well, if there are no other questions, thank you all.
Yeah, thank you, Alex and Maury. Really appreciate you both. This was great. And thanks to everyone for joining us today. I also want to just shout out that our next speaker series and our final speaker series in our spring series will be coming up on April 22nd, and we'll hear from Dave Van Horn here at UNM and his partners at the U.S. Army Corps of Engineers. So hope you will join us for that presentation as well.
Thanks all.